Hello friends, our today's question is minimum size subarray sum. Okay, so we are given an array of positive integer nums and a positive integer target. We have to return the minimum length of subarray whose sum is greater than or equals to target. If there is no such subarray, return 0 instead. Okay, so what is basically given in this question is we are given with a nums array and a target. Okay, so we have to find a sub array whose sum is greater than or equals to this target. If we are not having such sub array, so we have to return 0. So what sub array is like? If we are having array, so if we take some part of this array or this, so this is called subarray. So we have to find a such subarray from this nums array such that their sum of the element is greater than or equals to this target. So if we consider this now, if we take first four element of this subarray, 2 3 1 and 2, 3 plus 2 is 5 plus 1 6 7 8. So its sum is 8, which is greater than 7. So this is a subarray. Okay, so this is one subarray. If we take then 3 plus 1, 3 plus 1 4 plus 2 6, or this is 10. So this is also a subarray. Okay, again in this way, if we take this, so this is also a subarray. Okay, so we can have different subarray whose sum is greater than or equals to target, but what is given in this question is now we have to return the minimum length of the subarray. Like along all these subarray we have to return the minimum length of the subarray that can sum up to the value of target. Okay, so if we see all this now, this is the subarray 4 and 3, which is the minimum size, which is 2. Okay, which whose element sum ups to this target. Okay, so 4 plus 3 is 7. So we have to find this sub array. Okay, so what we will do, I think we have understood the question. Okay, so like in this case, in the third example, we are having target as 11 and total elements we are having are 8. So and each element is 1. So if we take all those elements, so its sum is equals to 8, which can never meet or satisfy the condition greater, which whose sum is greater than or equals to target. So in this case we will return 0. Okay, so now what, we have understood the question. Now for approach. Okay, to have the approach here now. Okay, so here we will use sliding window approach. Okay, because we have moved in the sliding window section of this 150 questions, so we will use sliding window plus 2 pointer approach. Okay, so what sliding window is like, we will take a window. Okay, like this, we have taken a window and we will shift it, and we will find, like in this window, if we are able to satisfy our requirement, so then the required window is a solution, otherwise it is not. Okay, so what we will do for that, now we will have two pointer. Okay, both left and right. Okay, so we will have two pointer which both will be pointing to 0. Okay, because we have to find our like a sub array. Okay, so both pointers are here, left and right. Okay, so what we will do, we will have a variables current sum. Okay, like let's say sum. So what we will do, uh, we will sum the current value which is pointed by r in this sum. Okay, and we will increment the r. So we will increment the r up till we does not find a sum which is greater than or equals to target. Okay, now so in this case, like r is here. Okay, so okay, so once we will find the sum which is greater than or equals to target, now then what we will do, we will have left pointer which is on its original location where it was previously. Okay, so what we will do, we have to find the minimum. So if the sum is greater than the target now, so we will try to remove from left side. Okay, so we will remove up till the sum is greater than, we will remove element from left side, which is from left pointer, up till the sum is still greater than or equals to target. Okay, so in this way we can find the minimum sub array, which minimum length of sub array which will sum up to the target. Okay, so now let's try run and understand this problem statement. Okay, so like we will have left pointer, we will have right pointer, we will have sum. Okay, and we will have max length. Okay, let's say max length, so both initialize to 0 0 0, and max length, let's say it's int, it's the highest range of integer. So okay, so let's say it is int max. Okay, because we have to find the minimum, so every time we find we enter into the enter into a situation where our sum is greater than or equals to a target. In that case we will calculate the length, okay, and we will compare it with the max length, because whether the value which is contained in the max length is greater than, still greater than the value which we are having. If it is still greater, then we will replace its value with the new value which is smaller in size. Okay, so this we will do. So what we'll do, we will have left and right pointer here, so we will iterate right pointer until it's reached the end. Okay, now what we will do, for each iteration we will add it to the add its value to sum. Okay, whatever the will be the pointed by right pointer, we will add it to sum. Okay, so what we will do, first of all we will while we will iterate while r is less than n, where n is the size of, let's say, this nums array. Okay, so what we will do, we will add this into our sum, so it will be 2. Okay, now 2, so it is still less than our target, so we will continue adding. So it will, r will move to next pointer, so its value will be 5. Okay, so its value is 5 now. Still it is less than target, so again we will move to next pointer, so r will be here. Now its value is 6, so still it is smaller, so we will move to next, so it will be 8. Okay, now r is here, we have added its value, and our current sum value is 8. Now it is greater than the target, so what we have decided, now we have to find the minimum. So in search of finding minimum length, we will try, like we will check if whether we will remove the left element, so whether subarray sum is greater than the target. Like after removing whatever pointed by left element, left pointer, if we remove this element from the sum, so whether its sum remains greater than the target. If it is, then we have eliminated one element, so our length will decrease by 1. Okay, in the same way, so because we have to find the minimum length of array, so that we will do, so we will check if whether while removing, after removing element which is pointed by left, after removing this, the sum value is still greater than the target, so 8 minus 2 is 6, so it is not greater than the target. Okay, so now we will check. Here we have find length 4, so we will replace this with 4. Okay, now what we will do, we will again increment the value of r. Okay, and add this, so it will be added, so it will be 12. Okay, now we will again check. Now it is greater than the target, so we will check whether up to, we will remove element up till uh, uh, after removing element of the left side, sums is remains greater than target, so we will remove 2. Okay, so l will be incremented here. Okay, so it will remain 10, so again it is greater than the target, so we will again remove the value. If 3, after removing 3, its sums equals to sum is equals to or greater than target, so yes it is. So if we will remove 3, so it will remain with 7, which is equals to the target, so it is satisfying our condition, so again we will increment the left. Okay, so now we have got our answer in between three elements, so again we will replace that with 3. Okay, now again our pointer will be incremented, and it will have 10 value. Okay, now again we will check whether removing the left element, our sum remains greater than or equals to target, so okay, again we will check. So if we will remove 1, so it will be 9. Okay, so l will be moved here, r is here now. Now 2 we will remove, so it will be 7. Okay, so l will be here and r will be here, so now length, we have find our sum. Now sum is equals to target. Okay, and now minimum length which we are getting is 2. Okay, so this is the minimum length, so in this way we will get our minimum length subarray. Okay, so now what we will do, we will try to implement this. Okay, okay, so what we have, we have our left pointer, uh, int l is equals to 0, then we have right pointer, r is equals to 0, and then we will have let's say current sum is equals to 0, then int length, result, let's say result is equals to int max. Okay, int max, then int n is equals to nums dot size. Okay, now what we have, now we will iterate until r is less than n. Okay, this will be a termination condition. Now what we will do for current value of r, we will add it to current sum plus is equals to nums of r. Okay, okay, nums of r. Now while we have added our current value which is pointed by r in our current sum. Now for after adding after each time we will write here the condition like until if the sum is greater than, like while current sum is greater than or equals to target target. So this loop will run until our current sum is greater than target, and we will remove elements from left side so that we can get the minimum length. Okay, so and after removing each iteration we will calculate the length. Okay, so we will result, we will store the minimum of result comma r minus l. Okay, now what we will have okay, so now what we will have r minus l plus 1. Let's calculate this. If we are having r here and l here, okay, so l is here because l will be incremented after the value is removed. So r value is 5 and l value is 4, so 5 minus, so it will be plus 1. Okay, so result r minus l, then what we will do, sum, we will subtract current from current sum, C rent current sum. What we will do, we will remove nums of l. Okay, then we will increment the value of l, and after this loop we will increment the value of r. Okay, now this is the, now one thing we have to find out, like result is int max, so we have to take care of this condition. So while we will returning the result, we will check if uh, result is equals to int max, then return 0, otherwise return result. Okay, now let's run this. Yes, so it is accepted. Now let's submit. So it is submitted. Now for the time complexity, as we are iterating through this r from starting to end for the length of n, so its time complexity will be capital O of n, where n will be the length of this nums array. Okay, so thank you for watching.